We are at the real official Real Pro Clima Studios today.
Well, it's not really the Pro Clima studio.
It's like
we're at Pro Clima HQ in Sydney.
This is super exciting.
Who are our sponsors?
I think Pro Clima.
Yeah, I'm pretty sure Pro Clima are one of our sponsors.
I don't know if anyone's heard of them. Kind of a big deal. Before we introduce today's guest, we are in there. If you're not watching this by video, they're starting to set this up as a bit of a pretty cool hub training facility. So if you are in Sydney, actually really in Australia, you're going to come through Sydney at any point, keep an eye out for this hub. You guys are, I think, going to be using it in the future for educational purposes. What's really cool, well, I'm sitting behind me, they've got some commercial facade systems that you could break it down like a very 3D structured detail to understand how this goes together than trying to draw this on the...
Is this the new certified system that you guys launched?
Vortex?
Yes, Vortex Melio, so at Hero on its own, and then at Hero with Roku on the outside as an external continuous insulation.
Yep.
Then put whatever cladding we want on the front as a fully tested system.
Now, we have the smartest Pro Clima employee.
Is it?
That's what we've been told.
Okay.
You're last month's employee of the month, weren't you?
Maybe. Yeah.
No, we are. We have Villy today. So I think we should say with all the Pro Clima staff we get on, the next day we're telling them they're the smartest. But I think you actually are. So you give Jesse a good run for his money.
What's your background, Villy?
Background, mechanical engineer.
Yep.
I come from Bulgaria and studied mechanical engineering in Denmark.
In Denmark. How long have you been in Australia for?
Almost 10 years now.
Yeah.
I came as an exchange student from my Danish university just to travel for a few months here and study, and look at me.
And now you know
you
the
got married.
Australian wife, 2 kids
yeah,
later.
right.
So now you know the NCC more than anyone else.
Much more than me, no doubt.
Maybe, yeah. In some sections, potentially, yeah.
So, okay, let's head down that road straight away. We currently are operating under NCC 22. As of May, we're about to operate under NCC 25.
Yes.
Depending on the state. I think South Australia, the only one that aren't implementing this. Is that correct?
I've heard Tasmania as well is questioning whether they want to do it or not.
Okay, but then it's going to be frozen for 3 years.
Minimum, yeah.
Minimum. So we won't see any changes. Now, arguably, you could say that this is the most dangerous code.
Sure, potentially, yeah.
Yeah.
A step forward from the 2022 code in some regards, but yeah, overall.
Yeah.
I
mean, it's probably important to say that a lot of the things we're going to talk about today are our opinion. So, I mean, like, I understand there was a little bit of hesitation there when we kind of asked you a very sort of direct question about the code. I think let's just appreciate to all the listeners here that we can talk about our opinion and maybe some things that we would or wouldn't do. And, please don't hold us to anything. Do your own research, do your own, investigations.
You sound like a conspiracy theorist there. Go do your own research.
No, all I'm just saying is I understand, Villy's here under the Pro Clima brand right now. And, I just want to give you a little bit of freedom to kind of, speak your mind a little bit about it, and knowing that, please don't hold us to anything, if it's slightly wrong or...
But as we've always said, even though Pro Clima are a major sponsor, like if there's something that we'd never align with, we'd say it openly, but just by chance we align with everything because they're pushing the industry, which is why I asked the question, it's the most dangerous. Do you want to explain why it could be dangerous?
From what we are concerned about the weatherproofing side of things, airtightness, condensation management, weatherproofing took a big step back in the 2022 code. So 2019, you had no option. You had to do a verification method. You had to do a performance solution and use a tested system. What moved from 2019 to 2022 is it allowed certain cladding types, metal cladding types, and certain timber and masonries to not require a performance solution and just follow a very prescriptive standard which had nothing to do with weatherproofing in the first place. So suddenly projects could go ahead and install metal cladding according to the metal cladding code and assume that it was weatherproof, which was not necessarily correct. We know that the weatherproof layer is the membrane layer, and those standards do not have anything about the membrane's requirements. So from our perspective, that was a big step backwards in the weatherproofing side of things, where the most damages come to in the first place, commercially.
I think what we need to understand, and the biggest concept that our industry gets wrong is cladding isn't the weatherproofing system, and we shouldn't be relying on our cladding to stop water because it will leak no matter what cladding you have.
So I'm going to ask a question. I actually know the answer to it. So what the NCC 22 is assuming is that the cladding system is the weatherproof barrier. Is that what it's assuming?
The way the weatherproofing provisions are written, yes.
Yes.
And so what does NCC 2025 then
No
say?
changes in terms of the weatherproofing side of things.
So
these standards remain as a DTS pathway.
So I understand as well when we push on some of these questions, because you guys are involved in some of the conversations on the standards committees and stuff like that,
Yep.
and there's probably certain things you can and can't say. Have they recognised that this is a problem? That
My boss, Jesse Clark, is the one sitting on the BCC and the Building Codes committees to say better whether they've recognized that or not. But me sitting on the standards Australia for the membrane standard, we haven't got there yet.
But the conversation's obviously been raised, so they're aware then that it's a problem.
Yes, so certainly the conversation is moving that everyone becomes aware that pressure is fully transferred onto the membrane. Membrane becomes the most crucial layer that we need to make sure is watertight and airtight, and membranes have not been testing for watertightness and airtightness well enough so far.
So I think we should break this down into two conversations, Haim. Walls and roof. Because
Sorry, you and I stick to two conversations?
Billy, you reckon it's like 5 conversations happening at once, if you're lucky. So
I've got like 4 different things written down on paper right now. Like I'm trying to work out where we're going here.
So
No, I'm just joking.
if I think let's start with, I would say the industry as a broad community have kind of worked out walls. Have we not?
Yeah.
Like
Residentially, well, yeah.
Yeah, I think, And I want to stick more to residential for the minute because commercially I need to do a bit more prep on that. But what I see is I think everyone, maybe again, we're in the bubble, but we understand the quality membrane on the outside, and we both openly use ProClima and have for 10 plus years. Ventilation batten system can't go wrong.
Yeah.
Taping windows, all that. Where I see the problem is the roof. And I think there's a few clauses in this current NCC which scare me. But also we still, and I won't use brand specific, you see the insulation that's foil with the insulation attached to it, the Anticon.
You can call it Anticon.
Anticon, yeah. That, from my understanding, is probably, well, if you install it now correctly, it's not doing its job. Or if you then don't install it, what am I trying to say here? It just shouldn't be used. But if you install it correctly, it's not having any benefit to the building. But then why aren't we then looking at complete wrapping a roof?
Can you just stop on that for a second? You're saying if it's installed correctly, it's not having any impact on the thermal performance of the home. Why?
Because you've got the batten system that you've got to follow the ventilation system. And then the moment that you have insulation with the batten system and it's not still air, it's not doing anything.
Yeah, I just wanted to clarify that because I don't actually think the code also specifies that you need to put a class 4 building wrap on your roof either.
So let's delineate already. So if you're talking about truss roofs where insulation is sitting on ceiling level, and the ceiling is not parallel to the roof plane, you can put whatever you want on the top of your roof structure. That could be Anticon fully vapor barrier, or it could be a class 4 membrane, and you still comply.
Okay.
As long as you ventilate that place in the climate zone, in the colder climates,
So
So how does that work then if you've got a warm roof scenario?
Warm roof scenario where you have a rafter type roof, insulation between the rafters, and you protect your membrane, your structure with a membrane, and fill the full depth of those rafters with insulation, then that membrane should be highly vapor permeable.
But so maybe go back, maybe to recorrect my statement then. It's on a pitch rafter of like what we would traditionally call a warm roof, where the Anticon then isn't. It's not actually doing anything.
No.
And I know you and I like to can the star rating, but by then putting Anticon on top of that, that can then add to your star rating or your R values on your roof.
But the insulation has it's the air gap.
No, I understand that,
like
but I'm just
system.
I'm pointing out a flaw in the system because you're saying that this is going to be R1, and then you're like screwing your roof hard down on top of and compressing it all down.
And we're not. This conversation isn't like around that ProClima products are the only solution. What we want to do is point out the big changes that are coming, because I go back to my comment, and my comment is that it's a dangerous code.
Yes.
So what I want to, so let's because this is like our brains are.
Bring it back, Matt.
Let's go back.
Bring it back.
You guys are laughing already. So the roof I want to touch on, because one of the biggest changes that we have coming on is that we've got what I understand, especially the truss roof, and it's currently part of the code, is we technically can't wrap a roof continuously.
No. You can't link the wall membrane to the roof membrane, keeping an airtight attic space while keeping your insulation at ceiling level.
Yeah, and that's the real clincher. You can do it, but you need to push your insulation to the underside of the roof sheets.
Somehow.
Which again, then you compromise the installation of the insulation. It's not continuous. So we have other problems that we introduced, but we're now allowing the building not to be airtight, potentially.
Yeah, of course.
And what issues would that cause?
Well, first, you're not allowing the building to not be airtight. If you dedicate an airtightness control layer on the inside of the structure, fully wrapped three-dimensionally across the warm side of the insulation, then you're going to achieve a pretty airtight structure. Intello. But their Intello needs to run on the underside of your bottom core trusses, right? But let's be honest, that's not the majority of the construction, right? If you don't do that, yes, you're going to have a leaky construction, especially a leaky ceiling. So hot, humid air will rise up and will find its way through gaps and cracks, and especially downlights and everything. So it's going to pass through a thick bath of insulation sitting on the ceiling level, everything fully air permeable and vapor permeable, and it will start going towards the cold elements of the structure upwards. That's the trusses and whatever goes at the top, whether that's the underside of the anticon or the roof sheet straight away.
So we can go back. Let's even go back a step here as well. What ultimately is the reason ProClima are here?
Healthy, durable, and energy efficient buildings.
So durable.
Durable, yeah.
So durable is a real key word here, because if we're not wrapping continuously, water kills buildings.
Exactly.
So do you think this is a huge flaw in the code?
You can speak on behalf of Villy and not on behalf of ProClima right now.
Yeah, of course. In general, building a truss roof in that configuration is suboptimal building practice, period. Like
by having the insulation on top of the plasterboard?
On top of the plasterboard, and then allowing air to freely escape through into your cold attic space. Yep. Have I seen too many damages and stuff? I haven't been on site enough to see this, but I'm hearing scenarios, especially in the colder climates, where structures rot, mold develops. We've seen a lot of documented evidence in North America where this thing can happen. When you ventilate that roof, getting that cold but moist air from outside, hitting structures that go beyond the ambient condition, and then you form condensation and mold growth over time on the underside of the roof sheet or on the underside of the membrane there. So not ideal.
So did these buildings have Intello?
No.
Yeah. And did they have mechanical ventilation?
Mostly no.
Yeah. So
make the assumption that they're code built homes.
Yeah. So which then I'd agree that clause makes sense for a code built house. That makes sense. I feel like if you were to have mechanical ventilation and Intello, the problem, it's not a problem. Having said that, there's no way to your woofie doesn't give us that 3D structure.
Yeah, that's correct. We can't do a reliable woofie calculation with a unvented attic space. It's a way too much air that can behave erratically in real life, and woofie can't account for this. The only way to do this is proper real-life experimental study. Like I know some people have done CFD, computational fluid dynamics calculations to assess what might happen.
What was that? What calculation?
Computational fluid dynamics.
Do you want to maybe
CFD?
No, but for us.
Yeah. So this is as you assign boundary conditions of this is house, this is outdoor air, this is air coming in, air getting out, and then you let the simulation predict how the air movement will behave in terms of its velocity and temperature changes.
Yep.
It's a lot more. It's kind of dividing everything into small pieces to assess cell by cell what's going to happen, which is not how Woofy works.
And have you done that on this situation before?
No.
Okay.
I've done this on much larger scales, like assessing ventilation in car parks or data centers or stuff like that, not roofs.
Yeah.
I know that
data
I know that
centers,
Clarence and Mark Dewsbury have done a lot of work on like existing buildings in Tassie around this exact stuff, like real life experience.
The University of Wollongong has been performing some CFD calculations and trying to link it back to a real building that are experimentally measuring things and assessing, can you open it only on the eaves? Can you open it only at the ridge? Do you need to open it top and bottom?
Are these studies funded by certain companies or are they actually independent?
Of course, they're funded.
Yeah,
they
yeah,
can't
I know,
work
but
for free. Yeah.
Yeah, I know, but like at the end of the day, like who's funding? Because if that's
The steel industry.
okay,
I
cool.
want
got
to
there.
show you that the
Matt.
steels do not
well led.
rust the structure. Yeah.
Yeah, so if the information comes out that's not beneficial to their product, it's not going to be, what do we call it, the blue scope steel rule?
I don't know who exactly the brand is. Yeah.
I'll say it. No, I can say that's exactly what was called out at the Building Physics Forum a few years ago. They raised this issue multiple times, and I think it was Mark. Don't quote me on it. But someone kept like, who's funded the study, and then you would see them try avoid. He's like, just answer the question, and it was really confronting when they would say who it was. And it's like, cool, and I understand that some people. Someone has to fund them. I totally understand it, and this probably goes back to our conversation with Ariana. Is like, but shouldn't all these, if we're using a university to study, that then should become public information no matter what. If you were to do it yourself, yeah, you can hide the information, but yeah, okay. Cool, we hit that topic. Interesting.
Here's a question: How does a company like Clima go about solving these problems?
Well, first and foremost, it's education. Like, you don't know what you don't know, and there are many people that we see in the industry. Architects and designers who I find are still confused of the role of membranes in buildings. They said, I'm putting a membrane to stop condensation. Okay, we're talking Intello maybe, but you're not putting an external membrane to stop condensation. This is kind of the biggest misconception I find. You're putting that membrane to protect that structure, and the risks of condensation are much, much, much lower compared to what it used to be back in the day when that membrane was a foil.
And this is where I get back to the durability. If we're going to start leaving bits and pieces of the membrane off, yeah, we might allow it to vent, but you know what's going to happen? Water's going to get in.
Yeah, exactly. And this is
and wind washing too. We haven't touched on that topic.
Yeah, of course. And talking about the code being dangerous, like the word membranes, it's a deemed to satisfy pathway for weatherproofing if you choose to use a membrane. Means you don't need to use a membrane. So you can still build a house with no membrane, walls or roofs.
When you say no membrane, you're talking about like a class 4 building wrap.
Yeah. That's
so
what I
you
mean.
can still choose to build a house without it.
Without it, yeah.
But which makes sense. Like think about hemp. You built a hemp house.
Yeah, but that's probably you're probably gonna have a performance solution based off that.
Yeah.
Yep, hemp is gonna be a performance solution. The masonry and concrete buildings will be exempt from the condensation provisions.
Wait. What? Why
Masonry and concrete? Why are they? The physics don't apply to concrete. I don't know why they're not. It's saying
you
it's
heard it
fully
here first,
exempt.
folks.
Yeah.
Physics does not apply to concrete.
But the brick.
So does that then? Okay, I can understand why they might do that because you've got WA, which builds double brick.
So they want to just
kind of makes sense.
It's just the big companies want to protect their product. Let's just say it.
Yeah.
Oh, yeah.
We're not saying which ones.
Yeah. The thing is, if you start talking single skin masonry, so what's your interpretation of this? Brick veneer?
Brick veneer, yeah.
But that's
Do you need to protect the frame behind the brick veneer construction?
Yeah, because if it's an unsealed brick like an old porous brick, the pressure is going to push moisture from out to in.
Of course, yeah. That happens. It's going to push that moisture in. It's obviously a structure is fully exposed during construction to start with.
Yeah.
And then you have weep holes that equalize pressure straight onto whatever the next layer is, which is the plasterboard, right?
Yeah.
Also, you have gaps and cracks and around window penetrations and stuff that you
Not with the
can't
Clima
expect.
products.
Yeah.
Use the Clima.
Yeah. But no, weep holes that water can be driven inward somehow at some point. Yeah.
Yeah.
We're talking specifically about brick veneer, right?
Yeah.
Yeah. Then what about concrete, precast concrete, in situ concrete, blockwork, permanent stone?
It's still porous.
It's still quite porous, but this kind of constructions do not have weep holes, do not have drain and ventilated cavity. The concrete is the structure, is the aesthetic, is the weatherproofing all in one go. So whatever is on the inside of that is technically protected. However, people want to keep that concrete look on the outside, and they put the insulation on the inside, and this is where you have the most dangerous situation. Internally insulated concrete with nothing to protect your concrete, meaning hot humid air from outside, past the insulation, gets into the cold concrete phase, straight away condensation and lots of mold.
Would it not be more of an issue from the inside with conditioned air from the inside then coming and meeting, I guess, that internal face of the concrete?
Exactly, yeah, that's the problem.
Yeah, okay.
But this is why this statement says you don't need to use a membrane there, because what the idea of membrane in the code away for now is that sits on the outside of the insulation. So you have concrete insulation, putting a membrane on the outside of that insulation will not do anything. You're not protecting anything because your concrete is fully sealed up, it's protecting your structure. So putting that membrane is A, impractical, you can't do that, and B, it's not going to be useful at all. So it's kind of giving you a free pass to not do anything.
So that scenario, to make that scenario safe where you've got in situ concrete and then an insulated wall on the inside, would you then be suggesting that you use an Intello?
100% in the colder climates, you can't make that wall work without an internal vapor controller, allowing so much infiltration
And
out.
especially now that concrete buildings are becoming way more airtight the way that we build.
Yes.
So it's even more, and if people start cooking and showering, that moisture's got to go somewhere.
Yeah.
Theoretically, build the concrete, install the windows and seal them up, do a blower door test. Now put your Intello in after your frame and insulation is in, do Intello in and do another blower door. You're probably not going to see any difference. It's equally as airtight.
So you're saying in this situation, it should, so from outside to inside should be concrete, then Intello, then insulation, or concrete, insulation, Intello?
The latter.
Yeah.
Concrete insulation Intello, so that Intello stops the air and vapor migrating through the insulation, hitting the concrete. And this is the most compromised scenario. Like, we need to understand that this is how Woofy was born in the first place. Like when Germans started renovating heritage buildings and they started bringing energy efficiency to the equation, of course they wanted to keep the look of the old masonry on the outside.
Yeah.
The only solution was to put the insulation on the inside, put it on, problems started occurring. They get involved with the building physics side of things to assess why this is happening. And that's where Woofy was born, to assess the movements of moisture and how to solve it. The ultimate scenario is put everything on the outside to keep that concrete warm.
So you go back to the conversation before, what did you say, that you can't have an air tightness on the outside of the building? What did you say? You said something along...
You need to have the membrane being watertight and airtight on the outside to pressure equalize the pressure. Yeah.
Because ultimately, if we built completely airtight, like to me, imagine a building, everything's fully sheathed and fully adhered. That's perfect.
It's pretty airtight.
And then you insulate then on the outside of that.
Yeah, that's the
you could use the rock wool that you got behind you or wood fiber board.
Wood fiber on the low-rise buildings, no problem. Yeah, it's a good solution for sure.
The ultimate.
So we've got two scenarios behind us, both test certified systems.
Yeah.
I understand external rock wool. I'm actually pointing behind me, and there's two stands behind me. One's got external insulation on a Hero. The other one doesn't have external insulation.
Yeah.
Like, intuitively, I'm looking at this one here without the external insulation with a steel frame. Now, I understand why it's steel because it's commercial. In my mind, that's a risk of condensation.
Is it?
I don't know. It just in my mind, it
Well, you've got the Intello on the inside.
Yeah. So
but I'm talking about, like, is that steel frame going to start condensating?
So let's think about what happens. Yeah,
that's a good one.
Okay, so the risks of condensation are there, but the more problematic part here is the thermal bridging that they're gonna occur through the steel, right?
Yep.
So if you imagine a thermal calculation of this, you have the steel frame with insulation in between. So the path of heat resistance through the insulation is much harder for heat to escape than through the steel. So actually, the steel acts as a hot bridge. If winter, hot, warm inside, cold outside, you're losing a lot of heat through the steel. So actually the outside of the steel, where it touches the membrane or the board, is warm. So the risks of hot humidity hitting that is lower, technically.
Because it's warm.
Because it's warm, because you're losing heat through it. However, the inside of the steel frame is colder on that plasterboard layer. And if that's too cold, then you're going to get something interesting. So you get what's called ghosting.
Yeah.
You see images of black stripes across the plasterboard.
Yeah.
So the cold steel allows, and this is interesting. Okay, so getting a little bit
I love this.
nerdy physics here. Okay,
Yeah, this is good.
This is
I like
what I
this.
want.
so
Yeah.
when you have a cold strip, suddenly you start seeing black spots.
Yep.
What are these black spots? Initially, everyone thinks this is mold. Yeah.
Water.
Water? Where from?
The condensation from the inside.
If it's really bad, potentially it's going to get there, right? It's going to be so cold on that steel that hot humidity is going to hit that spot and condense and all long-term form mold. Initially on the back of the plasterboard, and later on it's going to propagate. But what you see on the internal face of the plasterboard as a black stripe is actually dust particles. Okay, it's dust particles from the air, especially if people are smoking indoors or burning a lot of candles. All these fumes will get attracted through the cold surface due to a phenomenon called the Brownian motion. Okay, you want a bit of history here? Brown was actually a botanist, yeah, not anything to do with physics or chemistry.
Yeah.
Then he found out through whatever he was doing with plants that when things get cold, nature naturally slows things down. So this is what's causing this problem. So the surface is cold, therefore movement of stuff in the air wants to slow down, and that's how the dust particles that are actively moving in the air get attracted to a surface and stay there.
So we have some pretty smart people in this podcast.
Wow.
I don't think we've ever had something so smart.
Yeah, and it's like, and I didn't, and I brought that up before not to try and catch anything out because I know that there's a lot of research that have gone into these two certified systems, and
Yes.
I just want to
These are from a
re-emphasize
durability,
that.
not an energy efficiency perspective.
Yeah.
Durability. So Pro Clima's obviously not going to put their name on a system if it's not going to work. But as I said, I look at that and go, oh, that's a thermal bridge. So it's really
100%,
interesting that that you'll consider that outer edge warm because of the habitants inside or living inside. Yeah, okay, interesting.
But we can go through why we're here. So where we are today in the commercial level side, and mostly where Resi is, you have flexible membrane on the outside of a structure, right? Flexible membrane, once you go really high in the buildings, and especially in the high wind zone scenarios, these membranes pillow in and out quite a lot.
Yes.
You're going to risk every time that membrane is secured to the frame somehow via fastener to pillow in and out.
This is a great, so
let's just finish this and then we can come
this is
back
good.
to this. Yeah. So to account for this, we're moving on to a rigid board scenario. So you put external grade, non-combustible boards.
Is that the
in
Senat
high
board?
rise. It's either the Senat weather defense, external graded gypsum, or any of the fiber cement products that could be put as well. So this is what's where the pressure is gonna land from that building, right? The wind. It's not gonna allow any pillowing in and out. That board on its own is not weather tight. Obviously, to start with, you need to tape every joint of every sheet of board. But we know this is not enough from experience. The New Zealanders, the North Americans, the UK, we see that simply taping is not enough. You see corners keep chipping off, boards crack, especially when buildings move or excessive pressures hit the building. That's why we put full adhesive membrane, full coverage of that board.
So the Adhero has more flexibility than, say, the Exosana?
No, not really.
So you use
board,
it's like the sheathing, it's like the structural bracing, essentially.
Yeah, but the board itself doesn't deflect at all on the wind. Yeah. So this is where we want to move as the next step from the flexible system in high pressure, high rise scenarios to a rigid board system as a more durable, weather tight solution. And we're still keeping frame because that's the only thing you're allowed to build on high rise. And once we get that going, then we look into the better way of doing it, and that is by putting the insulation on the outside to mitigate the effects of the thermal bridging the steel causes.
Yep. So the major difference between the two systems is that the one with the external insulation is focusing on thermal performance, whereas the other one is just solving a problem.
Exactly, yeah. So that's the weather tight side of things is the fully tight. So once you add the Roku, we can take the four main advantages that you're going to see immediately. First, of course, thermally it's going to be much better. You have more insulation and you've mitigated the thermal bridging. The wall performs much better thermally. Second, you've actually improved the weatherproofing, whether you believe it or not. You almost don't get any water past the waterproof, the rock wool layer. And of course, two more things we rarely talk about, but this is fire resilience and acoustic performance is also greatly improved as well.
So, and what would people normally be doing in this scenario? Because obviously this is a certified system.
Silver sarking.
Yeah. So what would you normally see here? Steel frame, and then what Matt says.
What do they?
What would you normally do if?
Flexible membrane on the outside of the steel frame.
Like what's a flexible membrane? Like
could be the Extasana,
Yeah,
the class 4 Extasana.
Yeah. Okay.
Yeah, for majority of the projects that we see, yes, no, but could be any cheaper alternative competitors.
And I think the other thing to mention that makes it is really important is the UV exposure.
Yeah, of course.
So like you guys have 180 days.
180 days
And
tested, yeah.
what I learned during the week is that it's not the, with your one, and you can correct me here if I'm wrong, with the 180 days, the water tightness won't change. It will stay pretty well. It actually just loses its air tightness. Is that correct? After 180 days?
Good question. So let's dive a little bit deeper here. So first, what are the requirements about membranes and tested before and after UV? The 4200 Part 1 standard is very vague around that, puts it in a chamber for 500 hours and doesn't equate this to real life. So we're actually following brand protocols for now, but I can tell you, being on the standards committee for the next revision of the 4200, we are in much deeper conversations on how to make this a lot more relevant to the industry and how to make it better.
And there's a lot of brands out there claiming 180 days that aren't providing testing. I don't know, you can't comment on that.
Exactly. No, but the thing is, tested to what is what everyone is going to question, and you can technically say whatever you want if you're not...
tested to Matt and Hamish's standard, and we say it's 180 days,
So, okay, you tested, but what do you need to do before and after? You test your unaged material, so brand new from the production line, you age it naturally or artificially in a chamber. What do you test after? Currently, you only ask to test one of two mechanical properties for either tensile strength or burst strength, where a bolt pushes through the membrane.
So you look pretty big. You've been at the gym. Do you sit there and you're punching them?
You need to make sure that the membrane retains 85% of its strength. And if you do this, you technically pass. But for us to follow the brand's protocols, we had to prove that both the unaged and the aged did not leak water, so maintain its water resistant properties, remained its strength for all strength parameters, and also maintained its air resistance. Now, this is a big can of worms. The way we test air resistance is very outdated. The test standard for air barriers is meant for old paper-based products which were expected to have some form of air leakage through them. So when we test any of our products according to this air tightness test, we get like below 0.1, means that you can't measure anything. Nothing leaks at all. So let's say to pass this test as an air barrier is very easy for our membranes. Yeah, that's why, again, this is another thing we're looking into, putting a lot more relevant and applicable air tightness standards. So going back to your statement, does the membrane loses its air tightness capabilities after UV aging? I don't think so. It still remains a good water barrier. It still remains a good air barrier. What happens is it becomes more vapor permeable because the UV, to a certain degree, degrades the functional layer on the inside, which is the most resistance to vapor. So it kind of becomes hyper-permeable class 4 membrane, which, by the way, brings you to a very important topic. What about the tropics, where you need a vapor barrier on the outside, but then a class 2 vapor barrier, and you expose it for 180 days, and suddenly this thing became more permeable. So not class 3, maybe even class 4 membrane becomes 1/2 or even 1/4 of its vapor resistance. Suddenly you're wrapping up buildings in the tropics that does not perform like you wanted to perform with the vapor barrier.
Jesus, this is awesome. I love it. So 2 parts here. Let's go into tropics in a second.
Yeah, sure.
With the membranes, have you guys actually tested it and go, when did it, would it fail? Actually really fail? Because you've got, your 180 days, I know that's what you guys guarantee. I'd be confident it last year. Have you actually ever tested to be it still perform well after 4 years out in the sun? I know you would never commit to that. Have you guys just for shits and gigs?
So first, to do this in real life, or to get a better understanding, you better put it in real life. Because to do such a long duration in the machine is going to be very expensive and costly. And also, it's going to take a long time. So I can tell you what's happening in Germany from our founder, Curiosity.
Yeah.
We've had some of the Mentor products, specifically the roof product,
Yeah.
sitting on the roof for many years. And then every now and then, at the 1 year mark, at 1 year and a half, at 2 years, they cut a small piece and go and test what happens, yeah? It's been many years before they might see that it no longer holds the water. And by the way, by holding water, I'm referring to Australian standard asks you to hold 100 mil head of water, 1 kPa. German standard asks you to hold 10,000 mil, 10 meters of water.
So that's, imagine like a UPVC pipe that's 10 meters high,
Yeah.
full of water, compared to 100 mil?
100 mil, yeah, for 24 hours.
What?
Yeah, the requirements we pass for water barriers are 100 times more than what we need to pass.
So hypothetically, it would last another 100 times past that for the Australian standards.
I don't know if you can do the
Yeah, no,
same.
no, I
linear,
know, but like-
maybe,
And are the products that we're getting here from ProClima, those products that are being tested to those standards?
yeah, of course.
Yeah.
'Cause these products come from Germany, tested to the German standards, and
Yeah, so they're not 100% tailored to our market, like the actual products. These are the actual products that are getting tested in Germany.
Yeah.
So the same Mento that I'm buying in Germany is the same Mento that I'm buying in New Zealand, same
Yeah.
Mento that I'm buying here.
The Exasana is slightly different because first, they don't build much of flexible stuff on the outside, and if they do, they may be using some of the Mentor products. Exasana was specifically developed for the Australian market, just to be blue, New Zealand, Australia and New Zealand, but yeah.
So now heading back to the tropics, and now
Yeah.
you've got another good point.
And sorry, just on the colour, does the colour mean anything?
Yes.
Not much. Perhaps it's
Thermal
color
efficiency.
temperature could get in during construction.
Like for the what's the term? What am
About reflection?
Yeah, that's there.
Very little. Like when you put a cladding on the front or a roof sheet on the roof and you have this air gap, a little bit will be reflected. It will only make sense if it's very shiny. It will only make a big difference if it's very
So we
shiny.
can
yeah.
get pinks and yellows and oranges.
You can, yeah.
Lighter told us lighter colours don't perform as well.
Not perform as well under UV, yeah. So then you can might get more damage from UV.
I would have thought the opposite. Like the black would attract it.
Then the new problem, if it's black, it gets too hot.
Yeah.
If it's exposed for too long, yeah?
Yeah, okay.
So you want to kind of find the middle ground and say sometimes lighter black, darker gray-ish into dark blue is what works best.
So now back to the tropics.
Yeah.
When you talk about like if they're extending out, they're becoming even more vapor permeable. Now we don't build in the tropics, and I find this fascinating because we don't. You kind of want to learn, but you're kind of not forced to, being from Victoria, to build in their climate.
Yeah.
But I actually find it, and I constantly say this, like Queensland like New Zealand is probably 10 years ahead of us, who are like 30 years behind Europe. Queensland's another 30 years behind Victoria.
Oh, probably, yeah.
Like they're still stuck in the dark ages.
And hello,
50s.
all our Queensland.
Yeah, I think the
viewers
Spice Girls
right
just
now.
come out in Queensland. So, but the tropics, I want to talk about because there's a whole misconception like, oh, we don't need to worry about this stuff. We got warm weather, but you're dealing with a completely different problem. You're dealing with humidity.
Yeah, loads of humidity, yeah.
Yeah. So you want to sort of more go into deep. Do you want to nerd out on? Is it what's the product? It's a blue product, the green
The
product.
green DA product,
Yeah.
class 2 vapor barrier. Class 2 vapor barrier, technically.
And what's the difference? So what class 2 means? It's less vapor permeable compared to class 4.
Yeah, much, much less.
So less vapor moves through. So
Yeah.
going back to the old days, like a silver sarking, they were basically vapor blockers.
Class 1, most of them.
Yeah.
Until they started putting holes in them and they became class 4, right? So perforated foils would be highly permeable because vapor and water will go straight through the hose. Yeah. But
So stupid.
not perforated, yeah, it's might be a complete
I
class
remember
1.
like
Oh,
20 years ago, you're just like, you could tell the difference between the two wraps by saying, oh, the ones that go on the wall has the holes in it. You don't want to put them on the roof because water will get through. I'm like, and that just seems so normal 20 years ago.
But you still use the ones on the roof on the walls anyway.
Probably.
Tropics is so challenging. And to be honest, we had Hartwig Kunzel, the father of Woofy, like one of the best building scientists on the planet, coming in from Germany with 40 years of experience. And I also
yeah.
asked him a few questions. Hey, would you do this or this in the tropics? And I was expecting a very concrete answer. I said, yeah, of course. No, terrible. He said, I don't know. I need to try. I need to calculate. I need to see what it is. There's no, it's not such a simple solution. The reality is, it's so humid, and you have to choose how uncomfortable do you want to be on the inside. If you can sleep at 30 degrees indoors, 80% humidity, and you feel refreshed and optimal human the next day, keep going that way. But if you want to be normal person and meet normal 21st century comfort levels, you kind of want to stay at optimal conditions indoors, right? No more than at least 25 degrees indoors and reasonable humidities. How do you stop so much hot, humid air from outside coming in? You have to have an airtight structure, and you have to have an air-conditioned envelope on the inside.
And a dehumidifier, like a constant dehumidifier.
And a dehumidifier, yeah, because you will not be able to reject that much moisture just by the air conditioning on its own.
So, like, what purpose then does insulation play in those cool, warmer climates like that? Because the thermal resistance is just not going to do anything.
Let's think about it. 40 degrees on the outside, and you want it to be 25 on the inside. So
you need insulation.
Yeah, you're trying to keep the heat out, not the cool in.
The cool in is second law of thermodynamics.
Yeah.
Hot goes to cold. So the hot wants to always come indoors. Yeah. So the hot wants to go to cold through your building. It wants to infiltrate in, right? So you want to stop it moving by air movement to start with, right? So putting an air tightness layer on the outside of the structure to stop that air coming in. But also, that's one way of heat transferring through convection by air movement. Radiation. And another way is through conduction. Radiation through the sun. Yeah, then you're shading.
You learned something from Cam.
I was going to say,
conduction.
Conduction. So convection is air movement. Radiation, that's where your shading becomes important, your tinting of your glass and how much glass you have. And then the last one is conduction, like touching a cup of coffee and feel your hands going. If it's 40 degrees outside, it means it's 40 degrees in your cavity, which means you're going to conduct through most of your walls 40 degrees to 25, so you want to resist this. So actually having the insulation there is quite important to let you use less air conditioning indoors to maintain your comfort. Yeah. So it's all or nothing, really. Either keep it very leaky, uninsulated, or proper airtight and
and tell me about so ProClimate. I think Jesse's study, the Australian study, says that like in Victoria and in most parts of Australia, we're using internal vapor control, external weather resistive barrier, but up in the tropics in certain climate zones. Jesse's saying one.
No Intella.
No Intella.
Yeah, only rely on the exterior air tightness.
And can you just like explain it to me like I'm a 11-year-old why I wouldn't put Intella on the inside?
Cause.
Because challenging, yeah.
Because I fucking told you so.
So here is the concern. So 11-year-old, let's explain humidity variable diffusion.
I've got if you can, I've got the maturity of 11-year-olds.
So we know how Intella works. It works that the higher the humidity is, the more vapor permeable it becomes.
Yes.
And the lower the humidity is, the more it stops vapor. So in the colder climate, it stops the vapor getting out in winter when you're heating your indoor space.
And then our ventilation system deals with the extra ventilation, extra condensation inside. Yep.
And rejecting moisture. Yeah. And then in summer, that moisture that may come within the structure from outside inwards, Intella opens up, becomes more permeable, lets that vapor diffuse through, and then the ventilation system will reject that moisture. Now, at its most vapor permeable state, Intella is not infinitely permeable. So if you have so much vapors from the outside trying to come in from outside, hitting essentially a not fully permeable surface, you can trap some of that moisture behind the Intella and within your insulation layer. So the risks are very low compared to what they used to do back in the day, specifically in North American climates where they wrap the building with
plastic.
So
they're still doing that though, aren't they?
They still do it in the super cold climates and still problems.
So I don't know if I told you this. I worked in Whistler for
Oh, in Whistler.
I
need to go there mountain biking.
It's incredible. We'll talk mountain biking afterwards. I was on one of these big, beautifully, real
chateaus.
Chateau, big steep roofs and stuff. And we started wrapping everything in plastic. I'm like, what are you doing? This is like blowing my mind, and they still do that.
Yeah.
But now knowing what I know, like these multi-million dollar buildings that are sitting, at the foothills of, or the base of Whistler, have probably got massive mold issues.
Inside the walls, yeah.
Yeah.
Yeah, but they're not breathing that in because it's covered by plastic. So
as
they
long
never know.
as you've figured out how to install it well and sealed up, it's all contained within, but it's not what you want.
No.
Not what you want.
Yeah.
No, because could it be degrading the frame? The timber
well,
frame?
it's
Big time, yeah.
Yeah,
The
yeah.
insulation will shrink depending on the type of
So
insulation.
anyway,
and stuff.
I hijacked that part.
Yeah, but so mold needs food source. There's obviously moisture coming in there, so that moisture become dry rot and rot out. The mold's not going to degrade the timber. It's the dry rot and everything else that comes.
So
Is that right?
just back to why we remove the Intello though. So the Intello is not fully vapor open, and there's so much moisture trying to move through that wall assembly
Some of it can get trapped. Yeah.
that it can be trapped. Yeah.
Yeah, some of it can trap.
It's like
an
a
awful lot of
highway.
it
It's
to
like
dry
a,
out.
it's like a big highway
Yeah.
that's just blocked up.
Pretty much.
Like
Yeah,
a
that's
car
a good way
crash.
of think about it. Yeah,
Yeah.
that's a good way to do it for an 11-year-old. Yeah.
Yep. Great. Okay. Cool.
Yeah.
So
now-
then remove the internal system, and then rather than have an HRV, we've got an ERV.
Anthropillary.
This is good. And
Is it anthropillary?
enthalpy.
Enthalpy.
Yeah, enthalpy-based core. Yeah.
Yeah.
I thought this was the wise thing to do, but some recent conversation with some sustainability engineers and passive house consultants there tell me that sometimes, perhaps Darwin specifically, or the really high tropics areas, ERV all year round is good, but they find around the Brisbane area, which is exactly around the time around the areas where we are not sure where Intello is a good thing or a risky thing, is also they find that ERV might not be as good as HRV core in the winter months specifically. They're finding that sometimes too much moisture is being lost during the colder months.
So it can get quite.
I actually asked Cam because the past, like my house, it's actually a bit more humid than I thought, but it's been humid. But Cam said it's a numbers game.
Yeah.
So you need to look at it that maybe 30% of the year you need an ERV, 70% of the HRV. So you take the 70% win.
Yeah. Okay.
Or if you're bothered to monitoring stuff, swap cores.
Is it the exact same unit?
Yeah, you just need to open the core, take one and put the new one in. Not the new
okay.
one, but
We-
the
So
other
I've got a
version.
Zender Q350. I can just swap my core over and that's it.
Yeah.
Oh, I'm going to Joel.
Yeah,
how
it's
much
not
is
a-
it? How much is a new core though?
Like $3,000.
I'm not sure. I have no idea how much.
But
are
I
they?
can tell that's more comfortable, like comforts. I can tell it gets quite
Yeah,
humid.
but are you splitting hairs though?
No, it gets quite. I'm sitting at around 60 up to 70, 80% humidity internally some days. But
In Melbourne?
in Melbourne,
Yeah.
in a passive house. But
Hang on, I'm going to challenge this for a second. Do you think that's going to change as your structure dries out though? Because you've been living in your home for what, 6 months now?
no, but outside's also been around 90.
It's
Yeah,
horrendous.
okay. Well, I mean, that makes sense.
Yeah,
then.
no, because
But-
like obviously I can't go from 90 down to 40.
Yeah,
Let's
but
see what happens
it'd
in
be
winter.
so. I mean, our hempcrete passive house stayed humid for a long time
Yeah.
as the big hemp walls dried out. Now, I haven't chatted with the client since, and Nelson, if you're listening, let me know. It'd be interesting to see where that's sitting now because it took a long time.
Yeah, you got a huge amount of moisture.
Took
in
a
the wall.
long
Yeah.
time for that to come down and dry
Yeah.
out. Yeah.
That's true on one side, but also, being so hot and humid outside, you're constantly bringing that humidity inwards, and you're dehumidifying Melbourne.
Because you're opening the door and
Yeah,
closing
so
the door.
a
and opening the door,
better idea would just be to put a dehumidifier in the house.
Yeah, but dehumidifier also heats up the home, and if it's too hot and you heat it up more to dehumidify, you need to use more aircon to keep it comfortable. Yeah, you can't win. It's quite challenging. Yeah,
So you talked about pillowing before.
pillowing of the membrane.
Yeah,
of
do
the
you
high
want to
winds,
explain? Do you want to explain what that is quickly?
Yes, of course. So, I mean, if you think about it, if you put a piece of cloth in between two standing members, if you blow against it, it's going to deflect in. If you blow from the other side, it will deflect out, and it's going to act like a parachute in and out between these two supporting structures.
And that happens on a residential building too?
On a low rise, of course, depends on the winds that hits that building.
So just a normal mum and dad house, double story.
It really depends what's around you. If it's a house at the top of the hill with nothing, no trees, no other houses around it, it will experience a lot of this stuff. If it is a house secluded within a small suburb with lots of other houses around, less so. But still, you experience something along 1 kilopascals of pressure, which is at a 600 stud spacing, is enough to deflect that membrane in and out, a solid
So this
20
is
mil.
Even with cladding
20
on.
mil.
Cladding doesn't make any difference. We have that a cavity that's open top and bottom. There's no pressure on the cladding. The wind goes past the cladding, past the hose, straight onto the
So
membrane.
20 mil commute. So this is kind of, I'm setting this up for a loaded question.
Okay.
But so because I'm massive advocate on my own house. We plied everything and membrane it. So like I'm big on using the sheathing as a full structure. One thing I've noticed, I have not had one architrave or anything crack and move. And usually I've noticed in a passive house, and I found very early you see the skirting in the corners coming apart a bit more quicker than I've ever noticed compared to it. I don't know if you've had that problem, Haim.
All the time.
Yeah, like it actually
in
comes.
fact, I say to clients, hey, on our 3-month defect liability day, we're going to come back and we're going to touch up those architraves because they'll open up slightly.
Yes.
Or they'll crack. They'll slightly
haven't
crack.
had that to the slightest fully. Now,
From
And
bracing
just for any potential homeowners listening, we actually glue our miters together as well.
and shoot them if you can.
Yeah.
But you just can't stop it. Now it's one thing I've noticed. I've had the same problem, especially when we did wainscoting. Big problem was it coming apart everywhere. And I mean, like you just saw the lines. It wasn't like a 5 mil gap. You couldn't slit a piece of paper, but it's noticeable. Now, peeling. What I'm getting at here is if it happens in a mum and dad house. What we have done in the past, and this is where I get to now, is our vertical battens and that we're using, everyone's seeing is starting to try save costs on material. They're cutting little blocks. On those little blocks are sharp corners that usually extend past the side of the stud. If that pilling becomes 20 mil, are we going to start ripping our membrane?
Very common in the brick ties of brick veneer. Like same things happens, even worse, a bit more exaggerated because it's a metal face brick tie with a very sharp corners on the end. When the membrane starts peeling out, it pokes a hole straight away, like very easy.
So with brick veneer, we should then be looking at a minimum of, they've got those plastic washers, or you should be putting on a timber vertical batten, or I put Nadec behind. I put Nadec behind all my brick or extra seal.
Yeah, so we've got a project coming up, big home, lots of brick everywhere, and we've actually talked about running strips. 20 mil, whatever, just so we can attach the brick ties to it.
So what you need? We just use offcuts of extra seal, and Chris, our bricky, we just give him a whole roll and go cut it up behind each one.
Extra seal or Nidec?
Well,
either.
I just use extra. We don't need a double sided for Nidec. I just use extra seal.
Yeah.
Normally Nidec is what we say because you double sided and put it on over there, but both will do the same job of
on a vertical
softening
plane.
that edge. It's still a little bit thick rubber to minimize this risk.
Where I get then, if everyone's doing these battens, especially on a roof, and they're cutting, because on a roof I'm assuming the peeling's even worse.
Good question. I think it depends
Especially
from where the wind comes from.
Because when you're building,
and
we might be wrapped outside, but you've got windows still open and it's like flying around.
Yeah.
I think we shouldn't be cutting out those vertical battens need to be continuous from top to bottom. They should not be little blocks because now we're adding, if you've got 5 or 6 little blocks along the way.
I don't know. I'm really interested to understand that because I'm all for trying to use as least resources as we possibly can. So, couldn't we put a camera up there or something and get a video of it? Like, I'd love to see this in play.
No,
what is it?
Mine's a lot of hypotheticals here.
Yeah, and I'm hearing what you're saying.
The same
and as you're sitting here saying this, I'm like, fuck, the last 5 houses I did have got blocks on
I'm
it.
the same.
I understand, and we see. I haven't seen too much of these small cuts on walls. I've mostly seen it. People avoid running full-length counter buttons for roofs. Only do the ASV system.
Yeah.
What I really don't know any evidence to say that the sharp edges of the buttons could cause this. One concern that could consider apart from this is the flat surface that you have at every button that water can pull on. If you have at every button, you have a flat surface. If water starts getting there, it will find its way through the screw hole.
We actually had that problem.
This is
where I had a leak come from that.
From a water tightness point of view, it's probably more concerning. But from a durability point of view, the billowing again is something else to think about. But of course, it's really a numbers game.
You go through and just cut
just shampoo. If you're going to cut them, just instead of cut them, just put your drops on 10 degrees on each cut. You're not changing any time. It
If
won't
it's
cost
not
any
too
more.
time-
You're still
consuming,
catching
yeah.
water though.
No, but it's on the angle, so it should drip and then hit.
Yeah, it should deflect the water easier.
Yeah, okay.
Yeah, it's much better.
All right.
But did you say you had ply? Did you want to link this back to the code? Because that's probably one of the most important changes in the new code that's coming, the 2025 code. So the way the code was written before said, in the code of climates, if you're going to use a membrane, it needs to be class 4 vapor permeable, right? You could put this on the outside of a metal sheet and still comply with that building code, which makes no sense from a building point of view, right?
Vapor blocker.
You have a complete vapor barrier being the metal sheet, but you put a highly vapor permeable membrane and then you meet everything, okay?
Yep.
Now the code explicitly states any control layer, okay? So introduces the word control layer, which could mean the membrane, it could mean a reflective foil that controls water and heat.
So are we saying controlling? Is that what we're using? Controlling.
Control, yeah.
okay.
Anything used to control anything, to control air, to control water, to control thermal, or to control vapor. Any one of these
Movement?
four pillars. No, not really, but
My brain went there too,
have
but
it,
yeah.
But anyway, now you have when you put in the realistic scenario, you're not going to be really layering too many things together. But the most expected thing to happen is on the outside of a frame, you put a board.
Yep.
To brace the structure, but also to resist wind pressures.
Yeah.
And overall, perhaps air tightness is better. Once you put that board, now you protect that board with something. Suddenly you have to meet this vapor permeance classification for each of these control layers.
But that's not my control layer. The ply's not my control layer. It's not there for. I'm not using it for moisture.
Yeah, but
Any
it
control layer.
becomes part of
You
your
will not.
control layer.
I don't think you. The way the wording is written is quite specific. You will not be able to argue that this is not doing any job.
That's why I asked the word movement, because is it controlling movement? Then we've got to
What the bottom line here is that every board that you're planning to put on the outside of the structure that's going to follow the new code has to meet the permeance classifications.
Yep.
And I have not seen many specifically timber-based products.
They're all going to have to
that
start sending off the
report-
Fraunhofer, because they are now liable because their product isn't vapor permeable.
Exactly. No one has been reporting vapor permeance at all,
Eggerboard.
vapor class.
Eggerboard has class 3.
Oh, yeah, perhaps class 3. Sometimes they haven't reported it, perhaps because they either haven't tested it or they have tested it.
Wait,
and
they
don't
also have
know
to be
what
class
it is.
4 then. Every ply board would need to be class 4.
The ply, the board itself class 4, and the membrane class 4 in the code of climates, yeah? This is going to start getting tricky for manufacturers, and I've been checking recently, and I haven't seen many manufacturers starting to report things
Well,
yet.
do you know what?
They have to.
We
The code is not there yet, but yeah.
We recently ended up spending, as an insurance policy, more money on going the OSB from performance membranes. We had a cheaper product by like a good amount of money, but they couldn't guarantee that the vapor permeance of that particular board. Now we could have got a sample and gone and tested it, but it's just one sample of one board, so the control levels are pretty low.
Yeah.
So I was speaking to Carter Holt,
Yeah.
and I asked them this question because we were looking at using it for our roof at the time, and they said, "Oh, we're thinking about getting this tested." And I said, "Well, you're liable if I put it on." And they had decided to send it to Fraunhofer. Now, I should actually follow up on this.
How long ago was that? I
Over
might
a year.
update you. Well, a bit less than a year ago, I heard that they've decided to put this on the lower list of priorities and not do it urgently.
Well, okay, I might follow up because...
But let's clarify. Sending to Fraunhofer will not solve much. They will test
Hang on,
it.
what are we doing when we're sending it to?
So Fraunhofer Institute of Building Physics is the birthplace of WUFI and a very dedicated center for research on building physics in Germany. So when you send a material to be tested to Fraunhofer, they test to, depending on the type of material, certain mandatory properties that needs to be tested. But all you get at the end of this is, okay, yes, a report of these properties, which then is fed to become a material data file in WUFI so that someone can perform hygrothermal calculations and assess the risks of using this product in a certain construction. So by a manufacturer sending their products, it's very handy for us and the industry to be able to do WUFI calcs, but it's not really useful for them. It could be actually quite detrimental to them because some calculations might show that things are not as good as they thought it would be. What manufacturers need to do is they need to send this to a third-party NATA accredited laboratory to establish the permeance class.
Is that expensive?
For vapor diffusion, it may be within 4 digits.
So,
So it's like $1,000.
yeah. Cam
2,000.
Cam suggested that we do it for one of our projects, and I think it was a few $100. Don't quote me.
Yeah, it could be.
But you've got to make sure you got the same batch.
No, that's exactly right. So Cam, we do the beer and BS stuff. So Cam's going to come on and talk about ply versus OSB. I think next month. So that's why actually when this comes out, who knows? But it might have been on. But Cam's going to come and talk about this. So it's really interesting when you start thinking about.
Geez, this could be a massive problem.
I think this has just come to light right now, and I'm really glad that we've got
engineers now liable. Like,
well.
By the way, that's all walls, right? Roofs, you don't need to do that to that degree. I don't think the way the code is written, even though that's probably where you're most likely to see a much thicker board.
That's where you're going to get the issues, though.
Yeah.
So recently, and I think I've talked about this before, we got Cam involved in a retrofit project, and we've essentially implemented your Adhero flat roof system. Yeah. But we weren't going to do Intello over the existing roof lining until Cam said, low pitch roof, you've got 12 mil OSB, and then you've got your Adhero. There is actually a small risk here. So we decided to lay Intello over the top of the raft.
Always recommended.
Yeah. And the reason I'm bringing this up is that I probably would have made the decision to not do it. But bringing on someone like Cam, who's obviously an expert in this area, is really important. So I guess the point I'm trying to make is,
let's do a whole episode on that topic. That's a great topic.
Get someone on your team that actually knows this stuff. Get someone like Villy to.
But my brain goes here. Like every house has some form of ply bracing, and they're typically using that cheap 3 mil.
Yeah.
4
and what issues are you creating there?
Like now you're like, is every engineer potentially now liable because I didn't specify a class 4 vapor permeable plyboard?
Well, they didn't need to comply to anything back then, so no.
But now they will.
Now they will. So when that code becomes active, whenever they need to be, they have to specify that.
Is
that
it
board,
from that point? From that point.
So Yasha,
onwards,
who listens to this podcast, is probably sitting here from Oronic.
Yeah.
Good note for you, buddy.
So we're expecting code to come in May 2025. So 1st of May 2026.
Yeah. Yes, that's correct. Yeah.
And then Canberra said it's going to adopt it within 6 months. So towards the end of 2026, any project submitted for DA and eventually for certificate for construction contract will need to comply with the new code. The Queensland has said 1 year, May 27, and then
so now they're 31 years behind.
Yeah, the other states not confirmed, expecting South Australia and Tassie not.
Victoria,
Who
knows?
Yeah,
I really love having these conversations because I've actually got a little note down here to have a chat with Dan about one of the projects that we've got in pre-construction right now, because I actually think that from what I've learnt today, we might create an issue in an existing part of the building where we've got an extension. And I won't talk about what project it is, and I won't talk about what detail it is, but rest assured, clients...
This is why we have the podcast to learn.
We are going to make sure that we're not actually creating an issue. So,
what else is happening in the standards? What are some other things? Ventilation battens?
Ventilation battens, not really. Like the way... So, in the condensation management side of things, we now care about the vapor permeance of any control layer, the board and the membrane. We also have mandatory drain and vented cavity on the code climate. 6, 7, and 8 has to have a drain and ventilated system.
Minimum 19 mil.
12, I just checked, just to be sure. 12 mil is how the draft came. The latest draft preview came. It used to, it started at 20, then dropped to 18, and the way it came right now is 12 mil. So you need to have a 12 millimeter gap between the back of the cladding and the front face of the outermost control layer.
What's 12 mil though, ply? But then if that batten is ply, does that have to be the same
fence
ply?
paling?
Is it?
But then that's straight of pine.
Minimum. I think the way it's written is to accommodate the shallowest possible metal top height you can put on a construction. So
the metals.
Yeah,
industry.
But that's to account for the commercial stuff more than anything.
But that's volume 2. Volume 1 and volume 2 are 2 different codes.
Yeah, exactly. But I don't know why they kept it across both. Maybe I was checking. Maybe I was checking Vol 1. Maybe Vol 2
I
is
checked
bigger.
it myself.
Okay.
Sorry.
Yeah.
Let's keep chatting. We'll see what else we can find.
Yeah.
Fact check. Let's
But
fact check and Villy.
This is important, and then you start introducing vapor permeance requirements everywhere. Before we used to have climate zone 4 and 5. Now 6 and 7 and 8. Now we have 1 to 8 with and without a drain and ventilated cavity. There are mandatory requirements of the vapor permeance of the control layers you're planning to put.
And so you can't direct fix cladding to your membrane anymore, which
in climate zone 6, 7, and 8.
which if you're doing that in any other state anyway, that's just one of the dumbest things.
I think one of the best things that have come out of like this whole social media thing is how freely information is shared now, and everyone that I see on social media now is putting ventilated cavities. They're talking about ventilated cavities, and this wasn't a thing 3 or 4 years ago, which I think is amazing.
But yeah, let's go back to if you're still sticking your cladding hard up on the membrane, every little screw or hole is just poking another hole in your membrane.
Yeah, of course. And also condensation, vapor coming out from the building condenses at the back of your cladding, has nowhere to go. There's no ventilation to dry it or drainage to drain it. So not ideal. And then if you're going to ask me later what we would want to see in the next revision of the code 10 years from now, is that direct fix is not allowed anywhere. It's probably one of the things
every
we want to see. Everything should be drained and
I
ventilated.
like how you said the next code update in 10 years from now.
But if you think about it, they stopped everything until 2030. Then they start considering doing something. Then it's going to take another 2 or 3 years. Might as well be.
Imagine the damage that can happen between the next 10 years and now.
Yeah.
Right, did you find it, Matt?
So
Roof.
what else is happening? Well, I can buy myself some time.
Roof ventilation requirements is now.
Volume 2, yep.
Can you do Control F?
Yeah,
Go much faster. This is a hack to anybody opening 600-page codes often. If you are specifically interested in the condensation side, if you go Control F for the search button I'm
an iPad here.
4200, and you're gonna shift a few pages from the first references.
What's the number?
4200. That is the membrane standard. It will pass it straight.
Pliable membrane.
Yeah, that's the definitions. A little bit more, and then you're gonna arrive straight to the code.
I'm not.
No, keep going.
No, it's not. I didn't do it.
Okay.
So I'll tell you an even better hack.
This is riveting.
So
Roofs, okay.
I know, an even better hack for your NCC.
Yeah.
Go to Google LM, create your own little bot, and then upload the NCC. It can then only refer to that document that you put into that bot. It can't go to anything external, and then you can start searching. So what I've done is I've uploaded any standards, any guides to standards and tolerance. So it's something that you can.
You can do that in any.
Yeah. I'm just using because I'm due. So condensation management is page 134.
Roof is now. If you're going to talk about roof, how I find it is that it separates the requirements for the ventilation, whether you have insulation parallel to roof plane, so typical rafter roof, insulation between rafters, the roof plane running in the same plane. The roof sheet running in the same plane, and then segregating this from insulation not parallel to the roof plane, sitting on the ceiling level. And then it's explicitly stating that, yes, how you're going to ventilate above or below the insulation or above or below the membrane layer.
And from a risk management point of view, you mentioned before about keeping that insulation hard up to the underside of whatever membrane you've got on the top.
Yeah.
So whether that's Anticon or whether that's a Mento or whatever, or even any roof sheets.
Yep.
What are the risks if we don't manage that? Because if you think about like putting insulation in between trusses, it's going to be tricky, and it's going to be tricky to make sure it stays hard up there.
Yeah.
So any truss manufacturers out there now, I'd love to hear your solutions for this. But what are some of the risks if it does sag down and you're creating that air gap?
So the fact that the air gap is there is not a problem. The concern becomes if that air gap is there and you have a lot of air moving in that gap.
Okay.
Right? So if you one of the ways to meet the ventilation requirements is to open up your eaves. So leave the insulation at least 20 mil short of the full depth of the rafters. So you have this 20 mil cavity, and then leave your eaves open to allow air to enter in and move in that 20 mil gap. Yeah. So is that a concern? Well, first of all, you're going to greatly derate the effectiveness of your insulation. Air moving through that layer. So just go back to basics. Insulation works on the principle of trapping pockets of air to insulate us from one side to the other. once you get air moving in that cavity, you disturb those air pockets within the insulation layer, or you're not really getting what you thought you're getting in terms of the R
the R
value of
values,
that bat. Yeah. So that is that a concern? It's probably just a bit of a inconvenient disadvantage more than anything. The concern becomes if you're bringing way too much hot, humid air from the external environment because it's so humid outside, and then your roof sheet and whatever is under your roof sheet cools down below the ambient conditions, then you start forming condensation on the underside of that structure. Where is that condensation is going to go? It's going to stay there. It's going to drip onto your insulation. It might wet your rafters. It's it's not ideal. It's not something we advocate for.
Yep.
We always say, if you're going to do this structure, full depth of rafter, covered with insulation, and the roof membrane links down
onto the wall membrane.
Onto the wall membrane,
Yep.
yeah, exactly.
All right, they've got it here.
Did you find it?
So,
It's a sub.
so it is here. So, where a pliable building membrane or sarking type material is installed as a control layer in an external wall, it must be located between the cladding and the external side of the primary insulation layer, be constructed from cavity battens, spaces or like, where applicable, with a depth of at least 12 mil.
Yes.
You're right. But it doesn't say only in certain climate zones anymore.
No. So then to get this, you need to get to the table below because it needs to follow this, and you see
It
that
doesn't say that. I'll report it does here.
it says it's the table itself is subject to X, and you see here that it says climate zone 6, 7, and 8, no cavity X. X equals not permitted. So this cavity.
So like the
only
problem
applies
doesn't
to
apply in
editor
those
shape.
states. But the other,
Yeah.
my other favourite one here is these don't apply to walls constructed from insulated sandwich panels or SIPs.
Yes, single skin masonry, single skin concrete, SIPS panels.
Is that because it's just
and
too hard
valve
for them to
roofs.
work it out?
Well, that's a whole different ball game with the SIPS panels and what exactly are your layers inside, outside, and what type of construction is sitting there.
But arguably
Sorry,
potentially one of the
insulation.
most dangerous if you've got ply.
Yeah, you don't want to mess up those. Yeah, for sure.
Having said that, those working with SIPs most likely are pretty advanced in their knowledge of building and going to be.
Yeah.
So I feel like
Yeah.
that.
You would hope so.
I feel like that's by default that will get covered quite well. But the issue would be if someone, an owner builder, was just going to do this and just put their cladding hard up. Imagine putting just a foam panel hard up.
Well, I think that exists because if you think about that particular product out there that it has the roof sheet, you know,
Bondor.
like sandwich like right onto the foam.
Yeah. So that's a foam insulation sandwich between metal on the outside and metal on the
inside, yeah.
Yeah, which is how Europe is building tens of thousands square meters of this stuff per day.
Wow.
And walls and roofs, yeah.
And can you, in your experience or expertise, is that a problem? Do you think that can be a problem?
The only time this becomes a problem is water somehow gets inside.
Okay.
And
So if we're managing the water during construction and post construction, then it should be okay.
Yeah, because it's meant to be pretty well sealed together, right?
Yep.
So it's gonna be your screw fixing points where you're gonna show
Yep.
the problem. So
Yep.
if you take care of this and not allow air to get inside that sandwich,
Yep.
you're good.
Yep.
If water gets in, problems start occur. Like technically you can't really do any rotting or any mold or anything, but you're gonna start corroding the steel
Yeah.
and
Interesting.
deteriorate the foam. Yeah.
We have a closing segment on this podcast, The Mindful Moment, sponsored by MEGT, Australia's leading apprenticeship experts. Now, the whole idea around this is to help give those wanting to learn piece of information, maybe a hot tip on something that they can do to improve their trade or learn more in their apprenticeship. You've got a huge amount of knowledge. How do you learn? Like, how can you give tips to young people wanting to learn more, but learn in the right ways? Like, how do you learn, and how would you give advice to someone wanting to get to like your level 100 on the ninja scale of condensation? We're probably at level 1, but how do you learn?
And not everybody has to get to 100.
Yeah. Where would you suggest someone is starting to learn this stuff?
This is a good question, and my head is going in a weird direction to answer this. I'm not gonna send you off to read stuff and watch videos. Find somebody, find a mentor. Like I'm so privileged to sit right next to Jesse Clark, leading building physicist in Australia, and Daniel Jacobs, master carpenter from Germany. that anytime I had a question or something to want to learn from, I can just turn around and ask them. And this is where I've learned a lot of it. Of course, I try to stay up to date with what's happening in the industry, of course, codes, but also what is happening overseas. But reading long papers is no fun. And a builder getting out of their way to read a 40-page abstract of a journal is not, I can't imagine being a fun activity.
I kind of like it.
Yeah, I would much rather point you to real people.
Just thinking about it.
Yeah.
So
real people that in the industry, you're going to be surprised how much more open for mentorship people would be to spend time with you. And
I reckon that's probably one of the best answers we've got. And I think you hit the nail on the head. Most people want to help people.
Exactly,
So if someone reaches out to you and asks for help, there's a really good chance that they're not going to tell you to fuck off and they're actually going to
not on Instagram, find our email, find our phone number.
Yeah.
Exactly.
Start there, but like, hey, now you said that you got two great mentors in Dan and Jesse, and both have played a huge role into our knowledge. Who's smarter?
The different fields, really.
Who's
of
taught you
course,
more?
Jesse doesn't have as much experience or any on the tools to see how stuff is built. This is why it was so funny joining and looking these two guys together. They couldn't piece it together because one knew how to do stuff and the other one knew why to do stuff, but couldn't figure out how to merge it together in an optimal way. Of course, they've done a tremendous amount of work over the years, two of them to where they were. But it was amazing to see joining out and then expanding the team and fitting all the pieces together, documenting things properly and communicating properly with the communications team as well, and it's all coming together much better.
I was really hoping you were going to say Jesse, so when Dan's listening to this podcast, he comes banging into your office being like, why didn't you pick me?
I'm going to wrap this up by saying, just circling back to something that you said earlier on as to why ProClima exists, and it's actually the second time that I've heard why you guys exist, and it says to educate.
To educate, yeah.
Like the fact that you just happen to sell products off the back of that, I think is great for a business. But one thing I have experienced myself over the past 8-9 years is how much free information ProClima gives out. So I guess on behalf of the industry and where me and Matt are sitting right now, you guys are doing such a great job. So, we really want to support you, and hopefully you guys can keep that up.
Yeah,
thank you.
perfect.
Thank you
for coming along.
Yeah.
Thank you very much.
Thank you, everyone.